Mm, I'll first briefly summarize Bill's paper by 5 diagrams. First one, a bunch of points. We may think there are 2 clusters, but when I generated them, I actually used 3. Then the problem becomes if we assume it's a mixture of normal distributions. Are there 4 parameters, the means and variances, or are there actually 6 parameters? So iHMM is basically a highly sophisticated technology that can estimate the number of clusters and the means and variances of them at the same time. So the first question to ask is, do we really need this high tech? We have the regular HMM. Do we really need to add this small letter I in front of everything? The answer is yes. As Bill explained already, compared to the regular HMM, also known as the regime switching model, iHMM has flexible number of clusters. And the alternative, structural break model, the problem with that is when you exit a regime, you can never re-enter. So those were the bad features. So iHMM is better. Also, iHMM is designed for non-parametric Bayesian estimation. The reason for non-parametric is obvious. We don't know the number of parameters. But why Bayesian? The maximum likelihood estimation is possible here. It needs expectation maximization. But the number of parameters here is very large, and it's changing after each EM step, which means it's really difficult to guarantee that the process will eventually converge. Also, GMM has never been done before, and I can't think of a way to find the moment condition at all. But Bayesian is basically sampling without actually solving or maximize anything, so I think Bayesian is useful here. The next question is, what is original about this paper? So the underlying interest rate model is a very old model. iHMM and the beam sampler is relatively new and is designed for other reasons, so it's okay. But I think the focus of this paper should be the technology is applied to a newer data set, the interest rate, which has never been done before. However, I think the paper spent too much time explaining the model, the method, and sampler, which is not right. I think it should probably spend more time on explaining the estimation results and discuss the intuitions. So at the end, the suggestions. First, model-wise, there is a newer base model where drift and volatility parameters are stochastic process as well. So the question is it possible to use iHMM on this one? Second, we added an I, so we can add an F as well, which stands for factorial. And this allows one observation to belong to multiple clusters at the same time. And the question, again, is it is applicable here. There is this other non-parametric Bayesian one focused on continuous infinite mixture, so we might want to try that as well. For the algorithm, I do not mean this particular sample here. What I was wondering is whether it's possible to find a more efficient, faster sampler for the specific interest rate model, because I think beam sampler is kind of very general. At the end, we could apply this to newer data sets where there are actually the problem of unknown number of regimes or clusters. For example, the speech recognition thing here, figuring out the number of clusters is actually important in that literature, or something more economics, the inflation rate. So that's all. Thank you.